Okay, dear students, so let's start with the light chapter. Okay, so what we actually study in the light chapter, let's start. Light. You know very well that light, what actually light is? May I know what actually light is? Is anyone here can explain me what is light? Light is a form of electromagnetic wave. What is light? Light, we can say that there is a different types of electromagnetic wave that we see like X-rays, gamma rays, UV rays. Okay, but light is a part of electromagnetic wave. So we can say that light light is a form of electromagnetic wave. Magnetic wave. Okay, it is a form of electromagnetic wave which has, okay, matlab ye type, matlab we can say that what actually light is. Light is a form of electromagnetic wave which has a particular wavelength regions. Okay, like I'm going to say that there are different types of waves that is going to have some wavelength of very large and very small wavelength. But we can say that whenever I'm talking about the light, so it simply means that we are just talking about a particular range of electromagnetic wave. Okay, particular range of electromagnetic wave, and that is 400 nanometer to 700 nanometer. Okay, so when electromagnetic wave is of wavelength range, that is 4 nanometer to 400 nanometer to 700 nanometer, then we can simply say that it is light, or our eyes are sensible to that particular range of electromagnetic waves. Like we can say that we are the voice we are audible, the voice that we can hear with our eyes, with our ears, is from 20 hertz to 20 kilohertz. Okay, 20 kilohertz. Okay, so this is the audible range audible range of our ears. Okay, audible range of our ears. Range of our ears. Okay, similarly the electromagnetic wave of wavelength 400 nanometer to 700 nanometer is, we can simply say that it is when it this particular wavelength this wavelength, or we can simply say that the electromagnetic wave of this particular wavelength when falls on our retina, then our retina is sensible to it. Okay, got it? Understood, everyone?
Yes, sir.
Abir, Ammar, and Hashit. Okay. So what is light? Light is an electromagnetic wave. Okay, or we can say that light. There are different scientists who give different definition. That some say that it has wave nature. Some say that it is particle nature. So Albert Einstein said that light has dual nature. Light has dual nature. Dual. One is the particle nature, and another one is the wave nature. Wave nature. Okay, how can we say that light has particle nature? How can we say that light has wave nature? So it can simply be understood by several experiments that we see that the particle nature of light can be understood by using that if the light falls on a shiny surface, like it is a mirror or a shiny surface. Okay, that this is the mirror. Okay, and when a light of a particular wavelength, or when a light falls on this shiny surface, then this light ray rebounds back at the same angle. Okay, when it falls on the shiny surface, like this is also shown by the particle. Like we see that if we hit a ball, okay, if we throw a ball, if we are having a ball and I throw it here, then it will strike, it will touch here, and then it will strike back at the same angle. So ball is particle. We can say that ball behave like a particle. In a similar way, light is also behaving like a particle. Okay. So this is angle of incidence and this is angle of refraction. And that is angle I is equals to angle R. This is followed by law light. Okay. So we can say that light has particle nature. Got it? Got it? And other example for this one is also that when we have a cesium metal plate. Okay. Cesium metal plate. This is cesium metal. Cesium metal. Okay. Metal. So when cesium metal, when a frequency and a light of suitable frequency fall on it, okay, then the electron start ejecting out from it. The electron start ejecting out from it. Okay, like in radium also. When the light falls on radium, okay, then the radium start glowing. Why it is glowing? Because of the electron displacement. So why it is possible? Why it is how it is possible? Okay, that and how it show that this is the particle nature of light. Okay, so how can we say that? Suppose if we are having a circle and in this I have placed some balls. Okay, tiny balls, and just I take this stone and hit it. Then what would happen? Is there anyone who can explain what would happen? Tell me.
So can you repeat?
I'm saying that if suppose I'm having a circle and I have placed tiny balls in it. This is tiny balls in it, and I hit a stone. Okay, I'm just throwing a stone over it. Okay, a stone. This is a stone, and I just hit a stone and hit over it. Then what would happen when it strike the balls, tiny balls? The balls will displaced and will move to different angles. The balls will displaced. Hmm?
Yes.
Will it happen or
Yes.
not?
Yes, sir.
Yes. Why the balls are moving?
Yes, sir.
Why the balls are moving?
Due to vibration.
Because there is something that is hitting. For example, if take another example. So if this is a car, okay, and if this is a car and another car strike over it, okay, another car B hit this car, both are moving in the same direction, but this car A and this is car B, the car B hit this car A. This car A is stationary, this is not moving, and this is moving. This is moving car. Okay. So what would happen when it strike, when it collide with this A? The A will also start moving or will displace to some distance or not? Hmm?
Yes, it will displace to some
It will
distance.
displace. So what is happening here is that light, you can understood here that when the light particles are hitting these, for example, this is a stone. Just come to this stone. Stone has mass and velocity. Mass and velocity. The product of mass and velocity is called momentum.
Momentum.
Okay. If it is going to have only velocity and zero mass, then it will going to have momentum zero. P value will be zero. Okay. So there is something that is going to have some mass, and when this mass object, when it is moving with some velocity, it is going to have some momentum, that is P is equals to M into V. And you have studied in the ninth standard that when a stationary object, this one is M1 U1 and this one is M2 U2. So when you hit it, okay, hit this car with this other one, then they will start and having another velocity that will be M1 V1 and M2 V2. Or simply the momentum will be transferred. Momentum will be transferred. Like this stone hit this another stone, then some of the momentum from this stone will be transferred to this stone. And momentum cannot be transferred without mass. Means an object which is having mass is considered to be have some having some momentum. Okay, without momentum, or we can say that without mass there will be no momentum. Okay, now you understood. So how momentum is transferred? For example, this is ball A, another ball B. When they hit together, this ball A, sorry, B will hit ball A, and in that case, simply we can say that ball B is transferring its momentum to ball A. Okay. Got it?
Yes, sir.
Okay. In the similar way, when this is a metal plate, and metal plates, you know that all the substances are made up of electrons, metals, all are made up of atoms, and atoms are going to have electrons. So when these light particles, when these light substance, okay, hit this plate, these electrons start ejecting out from this one. Electrons start ejecting from cesium metal plate. So it means that electrons are at zero momentum here, or we can say that they are not moving. Okay. When a light of suitable frequency fall over it, they are start ejecting like the stones are start ejecting from this circle. So it means there is something that is carrying some mass and velocity, means having some momentum, and that momentum is being transferred to these electrons. And that's why these electrons are moving, means these electrons start moving or ejecting out from this surface. So how it is possible? It is only possible when a mass object, because momentum can be carried by that substance that is going to have mass. If there is no mass, m0, and velocity whatever it is, then it will be considered as zero momentum. The momentum can be only those means a matter can have momentum which is having mass, and substance that do not have mass cannot have momentum, and here the momentum is being transferred. So if light is having mass, then it is, we can say that it is a particle. Moreover, there are several experiments that has been observed that we're going to study in the higher classes, that light do not travel like a like the water flowing from the pipe, that is continuous. It does not flow like a continuous in continuous manner. Okay. For example, if you are having a tap here, okay, if you are having a tap, the water is coming from this tap, okay, water is coming. So the water is continuously coming. Can you pass your hand to this way, means along the stream, and is it possible that your hand does not get naked? Oh, sorry, that does not get wetted.
Your hand will get wet.
Yeah, yeah, it had to wet. 100% surely it get wet because the continuous water is coming. This flow is
Yes.
continuous. Okay, now just imagine if you are having a chalk and you throw it on a fan blade, that is moving fan blade. Okay, that is moving fan blade. It might be possible that your chalk does not hit the blade. It might be possible because the blades are not continuous. Okay, got it? So in the similar way, the light also travel in a discrete manner. That is like the blade is coming from the ball. Sorry, from the gun. Okay, it travel like a bullet is coming, and that energy packets or that substance is called photons. We called it photons. Got it? So light has particle nature as well as wave nature. Wave nature we will explain you some other day. That is not necessary that I'm going to explain you each and every. Now today I have explained you that light has particle nature. How can we define that light has particle nature? That is of cesium metal experiment. When light falls over cesium metal, the electrons start ejecting. It is only possible when some mass object hit the electron and electrons get some momentum. That's why they are ejecting out. Okay. And similarly, the another experiment that when a light falls on a suitable on a shiny surface, then it is strike back, rebound back at the same angle like the ball, like particle behave. So this show that light has particle nature. In the wave nature, we're going to explain you some other day. Okay, got it?
Yes, sir.
Yes. Okay. Others are not responsive. You understood? Ammar and Hashid. Ammar, you understood?
Yes.
Okay. So let's move further. Now moving towards the next point is that light, the reflections, the law of reflection is very important. So let's start studying that light chapter we have divided into two parts. Light chapter we have divided into two parts. One is the reflection and another one is the reflection. Okay. So what is reflection? We are going to study this in two parts. Okay, reflection and reflection. So what is reflections? What is reflection? The bouncing back of light in the same medium when it strike a shiny surface. Okay, it's called reflections. What we called it? Reflection. Like when a light is traveling from air to some surface and then it is strike back at the same surface, then we will consider that we will say that it is obing, or the phenomena is known as reflection. Okay, so write down the definition of reflection. reflection. The phenomenon of bouncing back of light when it falls in the same medium, same medium, when it falls on a shiny surface. Okay, got it? Understood?
Yes, sir. Noted.
Okay. So let's move further. Everyone, others? Amar, have you written? And Hashid, have you
Yes.
written? So let's move further, dear student. Let's move further. Now there are laws of reflections. What are laws of reflection? Laws of reflection. There are some laws that light follows. Okay. Whenever we say that this is a reflection is taking place, then the law of reflection will be followed. Okay. For example, let's just take an example here. Okay. So we are having a glass, okay, or a shiny surface, and this is the normal. We normal is an imaginary line that is perpendicular to the surface of contact. For example, this is a surface, then the perpendicular to this surface is known as normal. Okay. If the surface is like this, then the perpendicular to this surface will be considered as this surface. Okay. And the perpendicular to this surface will be considered as normal. Okay. This will be normal. Okay. Perpendicular, these are all normal. The normal is imaginary line that is perpendicular to the surface of reflection. So got it? And the light that strike on the surface is considered to be as and the incident ray. Okay, this is incident ray, and the light that bounce back in the same medium is considered to be as reflected ray. Reflected ray, and this one is incident. Understood, dear student? And this one is normal. Okay. And the angle with the normal, we always measure the angle of incidence with the normal. For example, if I'm having this shiny surface like this way, okay, and if then the normal will be like this or this, tell me, A is normal or B is normal? In this
A
case,
is normal.
A is normal, which will be perpendicular to this surface of contact. Okay, this one is normal. Okay. So when a light strike on this surface, that it is making an angle of 30 degree to it. Okay. So the angle of incidence is always measured from the normal. Okay. And then similarly, will strike back in making angle of 30 degree. And this will be again we measure the angle with the normal. Okay. So coming to the point that what is the first law of reflection? First law of reflection. First law of reflection. What does it say? It says that the incident ray, sorry, the angle of incidence, the angle of incidence is equal to angle of reflection, i.e. angle I is equals to angle R. Got it? Got it? Yes, student?
Yes, sir.
Please note it down.
Noted, sir.
Noted, everyone? Okay, let's move further. Other also? Have you noted, dear student? Others one?
Yes.
Okay. Hashid, done? Amar?
Yes, sir.
Okay. So let's move further. Let's move further. The another one is that the second law of reflection. What does it say? Second second law of reflection. Reflection. What does it say? It says the incident ray, the incident ray the reflected ray, and the normal lies on the same plane. What does this means? What do you mean by this statement? Is there anyone who can explain that what does this statement mean? The incident ray, the reflected ray, and the normal lies on the same plane. Okay, let me explain you this. For example, this one, I'm just going to have explain you with the help of this 3D diagram. Very hard to draw. Okay, let's consider that this one is the positive. This one is the y-axis and negative y-axis. This one is the x-axis, positive x-axis and negative x-axis, and this one is the y-axis, that is from this one to this one. This one is negative y-axis, and this one is this one is positive y-axis, and this one is negative y-axis. Sorry, z-axis. It is z-axis, positive z-axis and negative z-axis. I understood. So there are different types of planes that you see here. That if I ask that this is a plane, this plane is made up of which coordinates, which axis?
Y and Z.
This is YZ plane. Okay, YZ plane. Okay, if I ask you that this one, this base is made up of which plane?
XZ.
Yes, it is made up of X and Z plane. X and Z plane. So let me give you an example here that what does this statement means, that the incident ray, the reflected ray, and the normal lies on the same plane. Okay, let me explain you this one. For example, I am just considering that this is a mirror. This is the mirror. Wait a minute. Now you understood? Now just take this. This is a mirror, okay? And dear student, just considering that this is a mirror, I'm just striking a incident ray over this one. This is the incident ray that is striking on this surface. Okay. Just considering that this is a YZ plane. This is YZ plane. Considering that this is a YZ plane. Okay, I got it. Understood? Hello.
Yes, sir.
Yeah. Okay. This one is YZ plane. Now, if incident ray is coming in the YZ plane, then it will be moving in the YZ plane only. If it is coming in the incident ray, is coming in the YZ plane, then it will be moving in the YZ plane only. And the normal will also definitely lie on this plane. It is not possible that the normal can lie in this plane. That is the exact plane. Okay. the normal will also lie in that plane. And it is also not possible that if the ray is passing through this one, okay, if the ray is passing in the exit plane, then it is not possible that the reflected ray can pass in the ZX plane. It is not possible. If I am saying that the incident ray is in XZ plane, sorry, YZ plane, then the reflected ray will be also in YZ plane and the normal will also lie in this plane. Now you understood?
Yes, sir.
Understood? Okay. So this is the second law of reflection that states that the incident ray, the reflected ray, and the normal lies on the same plane. Okay. So please make this drawing and write it down properly. Similarly, if the ray is coming, let me give you some example. If I'm just considering that this is the mirror here, this is the mirror. Okay, and if I'm just striking the ray from this one, okay, this is the incident ray. And if this is the plane is XZ plane, then it will be coming to the XZ plane. Okay, and then it will be, and here it will be normal. Okay, then it will be. I understood. Understood, yes, student? So this is
Yes,
the
sir.
normal. The normal and means this is it will not be going. The normal will not be going in the upper plane or some other plane. No, it will be coming in the same plane. Incident ray, the reflected ray, and the normal lies on the same plane. So please make this diagram and write down the second law of reflection. Then we shall be moving to the next part. Done?
Yes, sir. Done.
Okay, let's move further. Let's move further. Now, this so many times questions regarding to the first law has been asked in examinations. It is just like this one, that it sometime it gives you like this way. A diagram will be given to you, and it will be asked that in the given figure, okay. So this will be like this: the angle of reflection in the given figure, figure will be, tell me, what will be the angle of reflection?
60.
Yes, it will be 60. So most of the students used to write that if it is 30, they just understood that this is the angle of incidence. No, this is not the angle of incidence. Actually, when we calculate this whole angle is of 90 degree. And if it is 30, then this will be 60 degree. If it is 60, then the angle of reflection will also be 60 degree. Got it? That is simple. So the answer is 60 degree. Very good. Let's move further. Okay. Let's move further. Now, moving to the next point is, let's move towards the image formation by plane mirror. Before we shall move towards the image formed by plane mirror, let's move some important point, that is the regular and irregular reflections. Regular and irregular reflections. Okay. What do you mean by the word regular and irregular reflections? You have to study this one in 8th standard also. What do you mean by the word irregular and irregular reflections? Do you understand? You know, have you heard these terms before? No.
Sir, regular means like the light is bounced back like in a straight way. Like if the light falls on a mirror, then it bounces back in like one ray. But if it's like a jagged shiny place, it just light goes everywhere.
Yeah, I understand. You are correct. Okay. Like we see that if we have a smooth surface, okay, we have a smooth surface, then if the incident rays are parallel to each other, like incident rays are falling like this way, okay, then they will be moving in the particular direction. And if the incident ray are parallel, then the reflected rays are also parallel to each other. So this is the regular reflection. Incident ray and the reflected ray are parallel to each other. But what happens in the irregular reflection? For example, this is a irregular reflection sites. Okay, this is the irregular surface. So when the parallel beam of light falls on this surface, okay, like this way, parallel beam of light is falling. Okay. It's very hard to draw parallel lines with this pen. So they will not fall in a or they will not reflected back at this with the same angle of incidence, or we can say that they will not be parallel to each other. Okay, they will not be parallel to each other. So this is the incident ray, and the reflected rays are not parallel to each other. So this is irregular reflection. And this one is regular reflection. Here, reflected rays incident ray, if incident rays are parallel, okay, then reflected rays will also parallel. Okay, now moving to this point is, if incident ray are rays are parallel to each other, then reflected ray will not be parallel to each other. Okay, note it down, please, fast. Now, question: what kind of questions come from this text or from this topic is that, do the regular and irregular reflections follow the law, law of reflection? Tell me.
Yes.
Okay, how can you say that law of reflection is followed here? Law of reflection is followed in both irregular and irregular reflections or not? Yes, it is
Yes.
followed.
Yes, because both are reflection and these are all laws regarding reflection.
Yeah. So have you noted down, beta? Have you noted
Yes,
down?
sir.
Okay, let's move further. So what do you mean by the question come, does law of reflection is followed in irregular reflection? Answer is yes. How can you say that? That if suppose because of this or uneven regular reflections, or we can say that here the light rays are not parallel due to just because of some reason why they are not parallel. For example, if I'm having a cricket bat, okay, and I'm going to have some machine here that is throwing me the ball. If I place the cricket ball like this, bat like this, the ball will strike this and will move like this. Okay, whatever the angle of like this. Okay, here it is normal. But if I put instead of this way, if I put the bat like this, the ball will come to this way. If I put the bat like this, the ball will come and will move towards this direction. Since the light is falling on the irregular surface, okay, sometimes the light falls like this way. So this surface will act like, and the normal, this is falling normally. So the light will move like this way for this. But when the another light ray falls at this point, and the other light ray falls at this point. So this will be the surface, and this is the normal. This is angle is greater, so this will move like this way. Okay. And when the light, so there is different angles. If this one is, then this will be the normal, and this will be passing through it. Okay, are you understood?
Yes,
So
sir.
just because the surface is not regular, that's why the incident ray are not affected to the reflected rays. Okay, they are not parallel to each other. So let's move further, and that is the image formed by plane mirror. Next topic, write it down. Image formed by plane mirror. Before discussing this topic, image formed by plane mirror, let me discuss the types of images. Types of images. Types of images. Images. There are the two types of images, dear students. One is the virtual image, and another one is the real image. So what is virtual image and what is real image? Let us discuss one by one. We will write the point here. Okay. After discussing the image formed by plane mirror. So let's discuss the image formed by plane mirror, and then we'll put the difference between the real image and the virtual image. So let's discuss first of all that I'm just taking here the mirror, and this is the plane mirror. Okay. And I'm just placing, just considering an imaginary line here. Imaginary line. And I'm just putting a candle on an object here. Let's suppose this is the object. Okay. For forming an image, at least two rays must coincide somewhere, at some point. Only single ray is not, we cannot predict the image where the image will be formed. So for better understanding of there are so many infinite of rays that strikes at a surface or at a point where the image is formed. But at least for our understanding and for our study level, if we simply say that if they are the two rays and they are some striking at some point, then we will consider that these rays that wherever they are coinciding there, we will consider that these rays are meeting there and the image will be formed. Okay, so how many rays are they required to make an image? How many rays?
Two image. Two rays.
At least two rays must be there. Okay. So first ray we always pass parallel to the this is principal axis. Principal axis. Okay, imaginary line that is passing perpendicular to this striking surface. So the first ray will be passing to the top, from the top of the object, and will be parallel to this principal axis. Okay. So if the object is like this, and this is parallel to the principal axis. So if this angle is 90 degree, so this angle will also be 90 degree.
Yes.
Now, if ray is passing through it, then the reflected ray will comes to which path? Will it goes like this way? A. Will it goes like this way? B. Or will it comes over it? C. Which path is correct?
It comes over it.
It will come over it. Why it will come over it? Because the
Because
angle of incidence here is zero. For example, if I'm having this normal line and this is the mirror, okay, and if the ray is passing through this is angle 30 degree. If I decrease the angle 15, then this will come to the 15. And if I make this angle 2 degree, then this ray will come at 2 degree. And if I make this angle 0 degree along with the normal, then the ray will come over it. So in the similar way, if the ray is striking normally to the surface, then it will bounce back. So let's imagine that this is bouncing back at the, okay, it is moving. And let's suppose let's make another ray that is making some angle. Whatever the angle it is making, let's say it is also passing from the top and will be making some angle at this point. And this one is making the angle at this point. Okay. Now, let's suppose this is 30 degree. Will the ray will come to this 60-degree angle, or will make 30 degree with this one? Which angle will
30
get fall?
degree.
30 degree. So the ray will come back and will make the 30-degree angle with this, like this way. This is 30 degree. Okay. Now moving to the next point is, now these are the rays. Okay. The first reflected ray is passing over it like this way. And the second reflected ray is passing. The second reflected ray is passing towards this. Okay. So could you imagine that these ray, when I produce it, keep producing it forward. Okay. Will they meet? Will they ever meet?
No.
No, because they are not coming, means they are just their area is increasing. So that's why when I continuously start increasing this one, they will never meet. Here they are not going to meet. Just imagine that they meet, for example, or just for an instant, just imagine that they are meeting behind. Yeah, just pass. Imagine that this ray is passing inside the mirror, and this ray is also passing. Okay. So where they meet, they will form an image. So since these are not the original reflected rays. Where these are the original reflected rays. Okay, these are not original because behind the mirror, means these are passing behind the mirror, and they are the ray cannot, the light strike on the surface, it cannot pass inside the mirror. So we are just imagining that suppose they are meeting behind the mirror, and they here the image is formed. The image will be formed like this. Okay. So you will find that whatever the distance, the object is placed in front of the mirror. Let's suppose this is object distance. And then let's consider it as with a symbol or with a letter, that is U. And let's suppose this is the image distance. And let's consider that consider it with a letter, that is V. Okay. So you will find that object distance will be equal to image distance. Okay, that is, if this is, means you can simply say that U is equals to V here. Understood?
Yes, sir.
Now moving that towards this point, that let's consider that this one is the height. This is one is the height of the object. And let's consider this one is HO. It is the height of the object. And consider this one. This one is HI, and this is the height of the image. The other two students are not responding. Ammar and Hashid. Why are you not responding? Are you there in the class? Ammar, are you there? Ammar is not responding. Ammar, are you there? Hashid, are you there?
Yes.
Okay. So let's move. Here you will see that V is equals to U. Image distance will be equals to object distance. Moreover, the height of the object will also be equal to height of the image. You will find that the height of object will be equal to height of image. Means HO will be equal to HI. Understood?
Yes, sir.
Understood? Moreover,
Sir.
Moreover, you need to understood here one thing that uh, that distance is equal, the object is equal, but you see that this is an imaginary, means the original reflected rays are not meeting. These are the imaginary lines. So this is actually the this is not the real image, because this is what you are seeing here, that the ray actually are not passing through it. These are not the original reflected ray. We assume that the rays are moving or meeting behind the mirror. Okay, we will see that this is an imaginary image, or we can see call it a virtual image. What we call it? Virtual image. Got it? So the image form will be virtual image. Got it? Understood?
Yes, sir.
So the image will be one condition, what? Image will be virtual,
Behind.
virtual and erect. What do you mean by the word erect? Erect means upright. Upright means if you are facing or if you are looking into the mirror, then your face will be upside and the feet will be downside. But if you watch your image, a real image in some other mirrors like the concave mirror, then you will find that your head will move, your feet will comes upward, and your feet will, means you will find the image upside down. Means this, if I'm looking this hand, then this will be like this way. Okay. Moreover, one thing that you need to understand here is that whenever I am having a mirror, okay. So if I'm making the image of, like if I'm making image of B in front of mirror, then it will look like this way. If I'm looking the image of A, then it will be here A. If I'm looking the image of M, then it will be here M. If I'm making the image of U, then it will be U. If I'm making the image of L, then it will be L. A, A. Okay, this will be like this way. Okay, so you will find that the image is actually laterally inverted, means left become right and right become left. If I'm making N here, then it will be showing like this way, N. If I'm making the image like this of this square having some objects inside it, like this B, like this triangle, okay, like this K, and like this N. So the image formed will be first come before. This is the this thing, this surface or this part is nearer to the mirror. So this will be coming near to the mirror. So this one is triangle is same. Okay. N. So this end is nearer to the mirror. So I will make this nearer. Then this will be moving from this to this. So I will be making from this to this. And then this one. Okay. The K. These two are coming first nearer to the mirror. So this will be coming first to the nearer to them. And this part, this one region is behind, means it is after the, so you will find that this one is this one like this image. Okay, I understood how the plane mirror or make the images.
Yes, sir.
Understood. Okay, so let make these diagrams also. Have you written the previous one? Have you written this?
Yes, sir. I have written.
So let's move. Ammar, are you there? Still not there. So let's move further. The characteristics of image. Write down the characteristics of image formed by plane mirror. Okay. First one. It form virtual and erect image. and erect image. Erect means upright. Okay. Second, distance of object from the mirror is equal to distance of image from the mirror. Okay. Third point. Third point. Object distance, we have said in height of image, height of object. Object is equal to height of image. Height of image. In short, we can say that it forms same size image as that of object. Got it? Third point. Fourth point. It form a laterally inverted image. Inverted image. Understood? It form laterally inverted image. What do you mean by the word laterally inverted?
Where right appears left and left appears right.
Very good. So it become left become right and right become left. Left become right and right become left. Okay. Now, have you written all these points?
Yes, sir.
Sure. Abhi written?
Yes, sir, written.
Hashid? Hashid?
Yes.
Okay. Let's move further. Let's move further. So moving to the next point is the little bit how the questions arises from this points or the image from the plane mirror. Okay. So let's take a question here. An object is placed 15 centimeter from the mirror. Okay. The distance of the distance between the object and mirror will be A 15 centimeter, B 30 centimeter, C 45 centimeter, D 60 centimeter.
So distance between object and mirror or object and image?
Object and image, let it be object and image. Correct. Object and image.
Then it will be 30 centimeter.
Yeah. But it would be 30. Why? Because if it is placed 15 centimeter from this portion, so image will also be from 15 centimeter from this mirror, and the distance between object and image will be 30 centimeter. Got it? Got it?
Yes, sir.
Okay. There are some important points that we need to write about the plane mirrors. Right? Plane mirror always form the complete image of an object. Plane mirror always form complete image of an object. Whether the mirror is smaller, larger. For example, if you are having a this size mirror, okay, and if you want to see the image of an elephant or some bigger object, like this is a tree, and you are having a mirror like this. So this is not a tree, this is tree. Okay, and you are having this size mirror. Okay, so you can see that if you are if you will be there from here, if you can't see the complete image of this tree because the mirror is very small, but it will form a complete image. For example, if you want to see the this region, then you have to watch it from this region, and this will show you this region. And for example, if you want to see this region, sorry, this region, then you have to watch it from this portion, and then you will be able to see this. So you need to change your position, but the image will be found complete. Okay, got it?
Yes, sir.
Second point, if if a man wants to see his complete image in plane mirror, then the the size then the size of mirror he must required will be half of his height. Means at least he must have the mirror half of its height. Okay. If you are having a mirror, okay, lesser than his height, or a person wants to a person is 6 feet height in height, okay, and he wants to see his complete image, then the mirror should be at least 3 feet, okay, in length. So she is complete. To see him a complete of we can say that full view in the mirror, then he must need a mirror that is of half of its height. Got it?
Yes, sir.
Now last
Sir,
point.
but the
Hmm?
full image will only be formed if the mirror is kept at an angle, right?
Yeah, the mirror means he must be placed some far away from the mirror, and moreover, he must have the height of the mirror must be half of its height. Means if an object, if you wants to see a person wants to see his full image in the mirror, so you cannot see the full image at in a single time. You can say that the mirror form the complete image. It is true that if you want to see your means if you are having a small size mirror, then you can see your complete image. Take a chair, then you can watch your feet, okay, and then if you want to see your face, then comes down and you can see your face, okay. So that is that you need to change. You are not seeing a complete image in a single time, but you can see your complete image by changing the different angles. But if a person wants to see complete image in the mirror for a single time, means or full image, then he must need a mirror at least of half of his height. Okay, got
Yes,
it?
sir. Yes, sir.
Now moving to the next point is the virtual image and the real image. So I'm just writing here the points of the virtual image. The real image I will write when I will teach you the concave mirror. Virtual image. Virtual image is that image that can't be obtained on a screen. On a screen means if you want to see your face in on a screen with the help of planer, you cannot see. Okay, like on a projector we used to see the movie, that is on a screen we see, but it is not possible that you can see a virtual image because it is formed behind the mirror. So it is not possible that you can obtain that image on a screen. So can't be obtained on a screen. Okay, behind the mirror, it always form behind the mirror, behind the mirror, okay, and on the same, okay, behind the mirror, let it be, because we are not studying refraction here, so let it be behind the mirror, okay, and it is upright. Erect means upright. It is always upright. Means we will not see, we will not see that if there is a virtual image is being formed, then you cannot see that upside down image. Means if you are making the image with the help of this mirror,